Hello everyone. For this tutorial video, I'd like to introduce the concept of surface tension, including an explanation of how liquid droplets interact differently with different surfaces. Forces between molecules of the same type are known as cohesive forces, and this exists in liquids and gases too, as it exists in all types of matter. An interesting property of liquids is that they have an outer surface, whereas gases do not. This means that inside the liquid, all the molecules are exerting forces on each other, and so this cancels out. However, on the surface of the liquid, it is different, because by definition of it being the surface, there are no cohesive forces pushing it out, only cohesive forces pushing it in. And we remember that a pulling force is called a tension. Therefore, as we could guess by the definition of what surface tension is, the surface experiences a pulling force inside. However, the strength of the attraction depends on the chemical properties of the liquid. So, for example, water has a very high surface tension, owing to the attraction between the hydrogen and oxygen atoms in each molecule. However, soapy water does not, owing to the weak attraction between the water molecules and the fatty acids that make up the soap. The resultant effect of the high surface tension of regular water is that the molecules on the surface form a tight membrane. So objects that exert a very, very low pressure, such as a paperclip or a needle laying sideways, can rest on top of the fluid despite being denser and normally sinking. However, surface tension is very weak and sensitive to higher pressures. So, for example, a more massive object like a fingertip, or the same mass acting over a smaller surface area, i.e., if you put the needle in tip first, would both produce a pressure strong enough to break the surface tension. And so the object would go into the fluid like normal. Surface tension also explains why rain droplets assume a spherical shape, as the strong attraction of the molecules inside it would cause it to take up the smallest volume possible. You may also notice, when interacting with solid surfaces, that the water will either maintain a beady shape or spread out, depending on what it touches. And this is explained because it has an adhesive force, or an attraction between molecules of different types, to whatever surface it spreads on. For example, you may notice with a waxed car surface, the water droplets will want to maintain their beady shape. But on non-waxed paint, such as the walls inside your house, the water will spread out instead, as the attraction between the water and the paint is strong enough to overcome the cohesive forces inside the water itself. With this out of the way, I have covered everything about fluid statics, or the study of pressures in a stationary fluid. In the next tutorial video, I will begin teaching fluid dynamics, which is the study of how fluids flow, including an explanation of the pressures that causes this to work.
Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.